Hi guys, welcome to my most tutorials. Today we are looking at matrices. So a matrix, this is just a rectangular array of numbers in a row and also in a column, right? So we have got three special matrices that we are going to be looking at. We have got row matrices, meaning that your matrix will just be in a row. This is just one row, right? So on our first example, we are having 1, 2, 3 in a row. Our second example is just 2, 4, 6. They are all in a row, just one row. And we have what we call column matrices. It's just one column going down. Our first matrix 1, 2, 3 is just one column going down, and also 2, 4, 6 is a column going down. And then we have what we call square matrices. Square matrices, it will be the same number of rows and the same number of columns. As for 4, it's one row, one column. So this is a 1 by 1 matrix. But what about A, B, C, D? It's how many rows? 1, 2. 2 rows. And how many columns? 2 columns. That's why we are saying it's a square matrix. It's a 2 by 2, and the other one, it's a 1 by 1. And I also want you guys to take note of something. We have what we call equal matrices. I need you to take note of something. When we say matrices are equal, what do we mean? So we can have matrix 1, 2, 3 like that. Yes, it is equal to matrix 1, 2, 3 like that. But it will be mathematically wrong to say matrix 1, 2, 3, column matrix 1, 2, 3 is equal to row matrix 1, 2, 3. So these two matrices are not equal. I need you guys to take note of that. Yes, the first set of matrices, they are equal. That's okay. The second set of matrices, they are not equal, right? So this is just an introduction on matrices. So on our next concept, we are going to be adding them, multiplying them, and subtracting these matrices, right? But then before we do that, I need you guys to know the order of a matrix. We have what we call order of a matrix. So when we're talking of an order of a matrix, remember I said our matrices, they are always a row. Let me write row in full. We say row by column. You multiply your row by your column, right? For example, they give us a matrix X, Y, Z, 2, like that. What's the order of this matrix? How many rows do we have? 1, 2. We have got 2 rows. How many columns? 1, 2. So this is a 2 by 2 matrix, right? What about if it was like this? 1, 2, 3, and then 4, 7, 3. What's the order of this matrix? Okay. The order of this matrix, how many rows do we have? 1, 2. We have got 2 rows. You say it's 2 times. How many columns? 1, 2, 3. So this is a 2 by 3 matrix. Okay. We can also have a matrix like 1, 3, C, like that. What's the order of this matrix? How many rows do we have? 1, 2, 3. We have 3 rows. 1, 2, 3. So it's a 3 by how many columns? 1. So this is a 3 by 1 matrix, right? 3 rows, 1 column. What about the last example? The last example can be, we can put it this way. We say it's 2, 4, 6, 8, like that. What's the order of this matrix? How many rows? It's a 1 row. By how many columns? 1, 2, 3, 4. This is a 1 by 4 matrix. How do we get the order? You say number of rows times the number of columns, right? That's how you get the order of matrices. And then sometimes they can just ask you to give an example of a 2 by 2 matrix. They ask you to say, give us an example of a 2 by 3 matrix, of a 2 by 1 matrix, right? How are you going to do that? 2 by 3, 2 simply means those are the number of rows. I can say A, B, right? These are number of my rows, 2 rows. But then it's by 3 columns. So it's A, B. I can say C, D, E, F. Okay. My AB was to set the pace to say it's supposed to be 2 rows. But how many columns? 3 columns. So A, B, C, D, E, F. This is my 2 by 3 matrix. What about a 2 by 1? Again, my 2 by 1 matrix, I'm going to put 2 rows. 1, 2. That's my 2 rows, okay? But it's by 1 column, so that's it. I'm done. It's a 2 rows, and then by 1 column, I am done, okay? So you should be able to give an example of any given, even if they say it's a 4 by 7 matrix, you should know that 4 is the number of rows. 7, that would be the number of columns, right? See you on our next lesson, where we're going to be adding and subtracting matrices.